Assalamualaikum and hi. Um, in this video, I'm going to discuss about the Laplace transform. Okay, in specific, the properties of Laplace transform. But in this short video, I just want to show you the linearity property. We have three properties in Laplace transform. The first one is linear property, this one. Okay, the second one, we will discuss first shift property. And the last one is the multiplication by t to the n. But in this video, let me teach you on the linearity property first. Okay, so linearity property, if you are given a function f1 and f2, okay, where f1 and f2 is a function of time, okay, then you have alpha and beta, which are constants. Then when you want to take the Laplace transform of that particular function, you need to bring the constant out from your Laplace operator. Okay, so this is the process. Okay, you need to take out the constant from the Laplace transform, and then you just take the Laplace transform. Okay, you just take the Laplace transform here of the remainder, and you can refer the table of Laplace transform. So what does it mean? It means that, for example, if you have question A, if you have to take the Laplace transform of negative 2t cubed plus 7t, okay, you can simply refer your table of Laplace transform. What does it mean? It means that you need to bring the constant out from the Laplace operator. So now we have negative 2 as a constant. So we have negative 2. Just take the remainder. Just take the Laplace transform of the remainder, which is t cubed. Okay. And then plus 7t. 7 and t. 7 is a constant. Take out 7. Then you have to take the Laplace transform of t. After that, you just refer the table of Laplace transform. So we have negative 2 is just negative 2. T cubed is t to the n. You can refer your table now. So t to the n is n factorial. What is your n? Your n is 3. So you have 3 factorial over Sn plus 1. Sn. N just now is 3. So you have S to the 4. Okay. Plus 7 is 7. T. T to the power of 1 is your Tn. So your n is 1. So you have 1 factorial over Sn plus 1, which is square. So we have the solution of this one is 3 factorial. 3 factorials equals to 3 times 2 times 1. Okay, so that we have 6. 6 multiplied by negative 2, so you have negative 12 over S to the 4 plus 7 over S squared. So you already transform or converted from time domain to complex frequency domain S. Okay. Next, this one. If you have to take the Laplace transform of 11e 3t plus 6t, so this is a linearity property. You have more than one function, simple function, right? Okay, so you can break into two. Okay, one is this one, another one is this one, and then you have to take the constant out from your Laplace operator, then take the Laplace transform of the remainder, and note that all the function, when you want to take the Laplace transform of the remainder, the function exists in your table of Laplace transform. Okay, so this one you have take the Laplace transform of 11e3t, so take out 11, so we have e3t. Okay, enough. So plus 60, 6 is a constant, so take the Laplace transform of t. Note that exponent and t exist in your table of Laplace transform, so just refer your table. E3t is, you can refer EAT. Your A here is 3, so you have 1 over S minus 3. Okay, plus 6. T is t to the power of n. So n equals to 1. So you have 1 factorial, which is 1, over Sn plus 1. N is 1, so you have S squared. So you can simplify your solution. Understand? Okay. Let me give you another example here. Okay. Look here carefully, guys. Let's say you have ft equals to 1 minus t. Tak nampak? 1 minus t square. Okay. 1 minus t n square does not exist in your table of Laplace transform. Okay, so what you need to do first is you need to expand the function. So I already calculated for you here. 1 minus t square is equivalent to 1 plus t square minus 2t. Then I try to make it like this. Okay, then only I take the Laplace transform of your expand function. Okay, so we have Laplace ft equals to Laplace of t square exists in your table of Laplace transform. Oh, then we have negative 2t. So we can take out negative 2 out from our Laplace operator and then take the Laplace of t, okay, Laplace transform of your t, and plus Laplace of 1. So 1 is just a constant. If you take 1 out from your Laplace operator, still you have 1 here. You still have 1 here. Okay, do not put 0. That does not make any sense. So 1. So take the Laplace transform. So we have this one, 2 factorial over s cubed. Minus 2 is minus 2. T is 1 over s square plus 1 over s. Please, class, please don't do this one. Let's say Laplace negative 2t cube is not equals to Laplace negative 2 multiplied by Laplace t cube. Okay, this is wrong. Okay, you must apply the linearity property. Okay, the idea is if you use the if you use the definition of Laplace transform, okay, from 0 to infinity, e negative st, let's say your ft is negative 2 t cube, okay, dt, obviously you will take negative 2 out from your integration. So that is why, that is the logic of taking out your constant from your Laplace transform. So we have negative 2, integrate the remainder. Then you have the solution here in your table of Laplace transform. So that is the idea. Okay, another example. I add up one example here. Let's say you have 3 cos square t. Note that 3 cos square t does not exist in your table of Laplace transform. Look here. You don't have cos square t. We have cos at. A is a constant of cos hyperbolic at. You don't have cos square at. So what you need to do is you need to apply the what we call it, trigonometric identity first. Okay, this one, for this example, you need to expand the function. So for this kind of function, you need to do simplification of the function. So 3 is 3. Cos square t is 1 plus cos 2t over 2. Okay, plus. So then only you minus with 4 sine 4t. So here you have multiply 3 over 2 plus 3 over 2 cos 2t minus 4 sine 4t. Then only you take the Laplace transform. Laplace 3 over 2. So this one is 3 over 2 multiplied by cos 2t. So take out 3 over 2. Just take the Laplace transform of here. Negative 4, take out negative 4. So you have this one. So 3 over 2 is 3 over 2s. Plus 3 over 2 is 3 over 2. Cos 2t is s over s square plus 4. Minus 4 is minus 4. Sin 4t is 4 over s square plus 16. You must always refer your table of Laplace transform when you apply this kind of question, because this question does not mention apply the definition, so that it is easier if you can refer the table of Laplace transform. Please master the table of Laplace transform. So that's all for linearity property. Please do extra exercises on this. For the next video, I will discuss on